Everyone, welcome. Today, we're going to dive into a hazard that you can often feel, but you can't really see: occupational vibration. It's this invisible force that's a part of so many jobs, and understanding it is absolutely key to staying safe.
So let me just ask you this straight up. What if one of the most common physical forces you encounter at work was silently doing you harm? That's the big question we're unpacking today. And the answer, as you probably guessed, is vibration.
But before we get into all the dangers, we really need to get a handle on the science behind it. So let's start with the absolute basics. What is vibration, really?
Okay, I know that sounds super technical, but the concept is actually pretty simple. Just think about a guitar string right after you pluck it, or feel the hum of a car engine. It's just an object moving back and forth around its normal resting spot. You can almost picture it like a wave, right?
Now, to really measure this motion, we look at four main things. First up, you've got amplitude. That's just how far the object moves. Then there's frequency, which tells us how fast it's moving back and forth. Next is acceleration, how quickly its speed is changing. And finally, direction. Is it moving up and down, side to side, or forward and back? Each one of these plays a huge part in how that vibration ends up affecting us.
All right, so we've got this simple physical motion. But at what point does it cross the line? When does it stop being just physics and start becoming a real hazard to our health?
It all comes down to one simple thing: contact. The second you grab that power tool or you stand on a vibrating platform, that mechanical energy, it doesn't just stay in the machine. It transfers. It literally jumps right into your body, into your hands, your arms, even your spine.
And this is the transformation that really matters. What starts out as this totally neutral principle in physics, just oscillatory motion, well, it becomes a serious occupational hazard once that energy gets inside you. We're talking about real physiological stress, strain on your body, worse performance at your job, and yeah, even serious long-term health problems.
Of course, the risk isn't the same for everybody, right? The severity really depends on these four things: the magnitude, so how intense is the shaking; the duration, how long are you exposed to it; the frequency, which, as we're about to see, is incredibly important; and finally, the contact point. Is it just your hands on a drill, or is it your entire body rattling around in a truck?
So this brings us to the most important piece of the puzzle: us, the human body. How do we actually react when all this energy is being pumped into us?
And what's just wild is the incredible range of our sensitivity. Our bodies can actually feel vibrations from super low frequencies, we're talking less than 1 cycle per second, all the way up to 100,000. In a way, we're all like these finely tuned instruments.
But, and this is so important, that sensitivity isn't the same everywhere. This is the key. Specific parts of your body, your organs, your spine, your head, they're each uniquely vulnerable to very specific frequencies. It's not random at all. There's a deep principle at work here. And that principle, the secret ingredient that explains why some vibrations are just so much more damaging than others, is something called resonance. This is where it all clicks into place.
I mean, why is it that frequency, maybe more than anything else, can turn a simple little shake into a serious threat?
The answer is something called resonant frequency. The best way to think about it is, well, picture pushing a kid on a swing. You know how if you push at just the right time with just the right rhythm, matching its natural frequency, the swing goes way higher with hardly any effort? Well, every object, and that includes our own body parts, has a frequency just like that.
And this quote right here just nails it. When the frequency of the tool you're holding happens to match the natural resonant frequency of one of your internal organs, bam, the effect gets amplified enormously. The vibration doesn't just pass through you anymore, it builds up, causing way more stress and way more potential damage. That is the hidden danger.
So I'll leave you with this to think about. Knowing what we know now, that every tool vibrates at a certain frequency, and every part of your body has its own resonant frequency, which of the tools you use every single day might be operating in that dangerous zone? It's a critical question for your own long-term health. Thanks for tuning in.